Well, if it seems like things on Earth aren't already strange, our home planet just got a little stranger. There's a hidden symmetry that nobody knew about. Now, scientists are trying to figure out why this symmetry exists. And the strangest part, the answer may involve one of the most powerful and disastrous climate systems on Earth, El Niño. There's this curious thing about Earth. If you split it into the northern and southern hemispheres, you'll see that they reflect almost the same amount of sunlight back into space. But they look completely different. There's more land up north and more ocean down south. There are different clouds, different weather, and still, the energy balance is almost equal. The clever term for this phenomenon is hemispheric albedo symmetry. It's a bit of a mystery for us, but the reason might be simple. The southern hemisphere has more clouds that bounce sunlight back. At the same time, the north has more land and pollution particles that also reflect light. It somehow evens out. But then, things get more interesting. A group of scientists started questioning, what if this balance isn't only north-south? What if Earth is also balanced in a different direction? They dug into satellite data and found something surprising. There seems to be an east-west balance too. It's not a perfect line you can draw on a map, of course, but statistically, it shows up. If you split Earth along the 27° east and 153° west meridians, you'll get two halves that reflect almost the same amount of sunlight. That line cuts through Europe, Africa, Turkey on one side, and there's Alaska and a big part of the ocean on the other. Admittedly, these are very different places, but the numbers match. To figure it all out, researchers used 25 years of data from NASA's Ceres satellites, from 2001 to 2025. These satellites track how much sunlight Earth gets and how much it sends back into space. If the numbers are steady, the planet's temperature is stable. But if they change, the weather starts warming or cooling. The research team broke everything down: oceans with no ice, with ice, land, cloudy skies, clear skies, every piece of the system. And then they tested different ways of slicing the planet to see if any pattern stayed stable. Well, one of them did. That 27° east line kept showing a bizarre kind of balance. Both sides ended up with almost the same mix of ocean and land and a similar volume of clouds. They even had similar amounts of sunlight reflected from clear skies. At first, the researchers were skeptical. After all, Earth is a sphere, and if you slice it in enough different ways, you can sometimes find patterns that don't really mean anything. But when they started testing this pattern more, it didn't disappear. Even better, it showed a triple symmetry. First, this is the only east-west line that creates this balance. Second, it doesn't drift. It stays basically locked at 27° east all the way from 2001 to today. And third, both halves of the planet end up with almost identical amounts of land and ocean. But then, the question is, what's actually causing this symmetry? Right now, everything points to ENSO, the El Niño Southern Oscillation. It's basically a massive cycle where the Pacific Ocean shifts between warm and cool phases. ENSO shows up every 2 to 7 years, and it keeps flipping between three states: El Niño, La Niña, and a neutral phase. El Niño is the warm phase. The trade winds, permanent winds that blow from east to west at the equator, get weaker, or sometimes even reverse. That allows warm water to pile up in the central and east Pacific. Meanwhile, cold, deep water near South America stops coming up. This pattern affects the whole world. There is more rain in parts of the Americas, but the weather gets extremely dry in places like Australia and parts of Asia. La Niña is the opposite. The trade winds get stronger than usual and shove warm water towards Asia. As a result, more cold, nutrient-rich water ends up in the eastern Pacific. So, the weather usually gets wetter in Australia and Indonesia, and drier in parts of the southern U.S. And then there's also the neutral phase, when nothing exciting is happening and ocean temperatures are closer to normal. There's another curious fact. The name of this weather pattern also splits the system in two. El Niño, La Niña is the ocean part that's linked to temperature changes in the Pacific. But Southern Oscillation is the air part, meaning changes in air pressure between the Western Pacific near Australia and the Eastern Pacific near Tahiti. And because the Pacific is massive, this one system ends up influencing the entire world's weather: rainfalls, floods, droughts, heat patterns, even hurricanes. Now let's get back to that symmetry idea. The researchers noticed that the tiny year-to-year shifts in that east-west balance seem to line up with ENSO changes, and they couldn't explain it without something called the Walker circulation. It's basically a huge loop of rising and sinking air over the Pacific, which connects cloud systems all over the tropics. It's like a giant conveyor belt moving heat and moisture around the planet. That circulation changes where clouds form and how much sunlight gets reflected back into space. So, during La Niña, the eastern hemisphere reflects a bit more sunlight. During El Niño, the western hemisphere takes over. The system keeps flipping back and forth, and over time, it kind of anchors that symmetry line near 27 degrees east. Now, this means Earth's climate isn't a set of separate systems, it's all connected. And here's why we should care. We already know that Earth's albedo symmetry controls how much solar energy gets reflected back into space. Right now, it's about 29%, and even small changes in that number matter a lot for global warming. The problem is, many climate models still don't reproduce this east-west symmetry correctly, and we need to change that. Because if a model misses this pattern, it might also miss something even more important. And that's where things get a little worrying. The same climate system that helps maintain this balance is also responsible for El Niño and La Niña. And some researchers think the next El Niño could become the strongest in more than 100 years. It might hit already in 2026. Back in the past, a similar El Niño triggered droughts and a famine that wiped out up to 60 million people. In 1876, massive droughts spread across Asia, Africa, and South America. Rain disappeared for months, and rivers dried up. Crops failed over enormous areas. Over the next 2 years, millions of people were slowly starving. Historians think that up to 3% of the world's population didn't survive that disaster. Even today, it remains one of the most fatal catastrophes in human history. Now, even though modern technology makes us far more advanced than people from the 1870s, we still depend on stable weather for food, farming, water, and electricity. And El Niño has the power to disrupt our planet on a gigantic scale. The most unsettling part is that the past disaster was not caused by some single freak event. Researchers believe that those conditions developed naturally, and Earth's climate system can easily produce something this extreme again. Today, the world is much hotter than it was in the 1870s. So, if another Super El Niño appeared in the future, droughts could become even more severe. A powerful El Niño may already be building in the Pacific Ocean right now, and some researchers think it could become one of the strongest ever recorded. Ocean temperatures in part of the Pacific are heating up fast. In some places, the water might become more than 5 degrees hotter than normal. For the planet's climate system, this difference is massive. The danger is actually even bigger than it looks. Today, we have satellites, forecasting, global communication. But there are still weak spots. Food supply chains are actually under pressure, and many regions are already dealing with drought. Ocean temperatures have been breaking records for years. Some farming areas are becoming less stable because of weather changes. Extreme weather events are becoming more spread out every year. And a strong El Niño could pour gasoline on all of that.